Welcome to A Problem Squared, the podcast which is not dissimilar to a delicious cup of coffee. You think it's going to solve all your problems, and it doesn't, but you still come back to it time and time again because it's so relaxing and comforting. I'm joined by the host of A Problem Squared, Bec Hill, the espresso of the problem-solving world.
Oh, yeah?
Yep, small, lots of energy, but people don't see the preparation and pressure going on behind the scenes to produce that final result. And it is not pronounced with an X.
Nice.
Thank you.
I'm very impressed.
Don't
with
get
that
wrong. And I am Matt Parker, the overly complicated cold drip. You know, I say that out loud. It's more insulting than I expected. What I'm saying is, a lot of people say you can't, is all that effort and detail and, you know, unnecessary attention to detail necessary? I can't really taste the difference. And thank you for joining us. That was an adequate intro. I lost faith when I called myself a cold drip.
Cold drip.
No, not inaccurate, I would say, as I see that very much as my role here.
I mean, I'm trying to think of a compliment to do with coffee that would up that, but I don't know enough about coffee. Like, and you're not bitter, but cold brew might be bitter. I don't know.
That's true. I'm not bitter. I'm well extracted.
Yes.
Yeah.
I mean, you don't want to show off about that.
On this episode, I'll be running the numbers on graphene toilet paper.
I'm going to find out how much a book would weigh without ink.
And I will be dealing with the many, many of you who had opinions about my previous solution to how far you can see on Earth. Let's get to it.
Yeah.
So, Bec, we're here in person.
Yeah, if you're listening to this and you're like, this sounds slightly different, and why is Bec reacting so quickly to Matt's facial expressions that you can't see?
Where's that lag we've come to know and love?
We're in the same room together.
Oh dear. Well, it's like episode 2 was the last time we were simultaneously.
I know, right? And we're on 22 now.
Isn't that? It's
23.
No,
23.
023 this one, yeah. We
023.
went like 20, 21 episodes virtual. We were ahead of the curve on that.
Yeah.
We went virtual early 2020.
Yeah.
And now here we are.
Wow.
It's
what
exciting.
a journey.
Oh my goodness.
And for what? I'm getting back in the cupboard.
So at the end of this podcast, vote on if we should send Bec back to the cupboard or if... Does it detract or enhance the podcast to have us simultaneously in the same room?
All right. Get us on socials at A Problem Squared.
Just say cupboard.
Yeah,
or
don't
no
give
cupboard.
any context.
Cupboard or nubbard. That's what we want.
Cupboard or nubbard?
Yeah.
Nubbard.
Nubbard. That's one vote for nubbard.
Do you spell that cupboard but just with an N? Or
Yeah,
do you get rid of the P?
You know, I think you keep it.
I think nubbard is N-U-B-B-A-R-D.
No, we've got the P because it's like nup. That's the...
Oh, no. Of course. All
That's
right.
the response.
I'm sorry. Yeah. I should have known.
That's the joke I just realized now.
Well done.
Thank
I'm
you.
impressed.
So anyway, other than the highlight of hanging out with me this weekend, how have you been?
Don't know why I'm laughing when you said highlight. I've been good.
Been good?
I've been good. So since the last episode, Make Away, Takeaway aired.
You're now officially a TV star.
Yeah. And thanks to everyone who's commented on it or
It's
said
good.
that it's really fun.
I didn't mean to say that with a tone of surprise, but like it's children's TV. And I was like, okay, I'll probably like it because Bec's in there.
Yeah. It's interesting how many people have said that, like, I'm not surprised it's good for kids, but they're surprised that it's quite watchable for adults.
Yeah.
I don't know how much I need to make it clear that the stuff that I do, I very much do as if it was for me and then make it child appropriate.
Oh, 100%. Yeah. And I've seen you do both adult like stand-up sets and your kid stuff.
Yeah.
It's not dissimilar.
Well, that's it. Exactly. If you like my stand-up or anything that I do aimed at adults, you're going to like the stuff
the
that I
secret
do.
is Bec is always 100% Bec.
Yeah, that's it. This is...
This-
Absolutely. And I remember someone said to me when I announced that it was coming out, they were like, oh, well done, congratulations. I mean, I won't be watching because I'm too old for it. And all I could think was, like how, like what a sad thing to say is that you're too old.
I've aged out of your...
For a kid, like I think you can be too young for something because mentally you're not prepared for stuff.
Yeah.
If it's to watch or read something, you're
To this
never
day,
too old.
if someone just shakes car keys, I'm fascinated.
yeah,
you know,
that's
shining movie things, still I'm on board.
yeah, that's how I got you into the office.
Because Lucy and I was like, oh, Bec show's out. And so we brought it up on the ITV Hub player thing.
Yeah.
It also airs on CITV. And we did that thing where we're like, oh, we'll have a quick skip through and just see what this show's like. And so we watched a few bits of episode 3, but that came to a natural conclusion. And I went like off into the kitchen to get something. And I came back and Lucy's just still there happily watching away.
Yeah.
I'm like, you're still watching Bec? And she's like, no, this is great. Yeah.
It's
And
really...
she was engrossed.
It crams a lot in. Even I'm surprised.
It was better paced than I expected from a children's TV show.
Yeah. No, well, thank
Okay.
you.
Yeah.
Yeah.
I was impressed.
Oh, good. I'm glad. Thank you. I really
You don't
enjoyed
need
making
my
it.
approval, but I enjoyed it.
I'm hoping we get a second season. That
That'd
would be
be great.
delightful. A couple of other things. Oh, I've been doing Animator Z.
Oh,
Which
yes.
is the anime.
competing
If anyone
podcast.
listening, it's not competing. You
Can't
can listen
believe
to
you're
both.
Doing another podcast.
Have you seen how many podcasts I'm subscribed to?
I've lost track of how
none of
many
them
you do,
compete.
let alone listen to.
But if anyone listening likes anime or is wanting to get into one, we've just started Vinland Saga, watching one episode at a time and doing deep dives. And Vinland Saga is set in Viking times.
Yep.
We've been doing like deep dives on Vikings and stuff. So we've been talking to archaeologists and historians and
Ooh.
all sorts. Yeah. What about you? What have you been up to this last month?
I had my protractor confiscated. You know, occasionally, because we've been catching up all weekend, right?
Yeah.
And I'm like, there's something I'm like, I cannot tell Bec that I had my protractor confiscated because I want to save that
Yeah.
as a thing for the podcast.
Yeah.
Security took my protractor because they said it could be used as a weapon
Security where?
at the Shard.
Okay.
So the Shard is a very tall building in London, for people who
Yeah.
aren't familiar. It's the tallest building in London.
Oh, Matt, how far could you see from there?
Okay, let's not skip ahead. And I was going to go up the Shard. And I brought a protractor
I
with
don't
me.
know why that sounds like such a funny...
I know. So I was going up the Shard, and security's like, "Whoa, what are you doing? You can't take that protractor with you. It could be used as a weapon." And I was there with Hannah Fry, also another mass communicator. She had an inclinometer with her, like a spirit level that measures angles, and they also confiscated that.
Wow.
We were doing a thing where you can calculate how big the Earth is by measuring the angle to the horizon from the top of a tall building.
Oh, so this was a little bit of how far can you see?
It's exactly how far can you see.
Yeah.
But using that experimentally to work out the radius of the Earth,
Okay.
which was done like 1,000 years ago. People were doing this.
We're going up the Shard.
Going up the Shard. The protractor.
What did they
though,
use thousands of years ago before they had tall buildings, Matt?
I can't think of any other way to be elevated above the ground than to go up a very tall building. So who knows? I assume they were just floating. So they were just, they
did have magic and stuff back in those days.
you know the classic 2 kids in a trench coat routine.
Yeah,
Just that.
Yeah.
But 4 or 5 people.
Yeah.
And no
a
trench coat.
really long trench coat.
Yeah, no trench coat. This is before trench coats were invented.
Okay.
One guy at the top with an astrolabe measuring the angle to the horizon. So I was particularly emotional because I had handcrafted this protractor. This was not like some off the shelf. I just went and
But
bought.
you whittled it?
That is so close to being true. Would you like to see it?
Oh, you got it back then.
It's over there.
So describe it for the listeners. It is a large
let me
piece of
grab it. Hang on.
perspex. Oh, yeah. I would say, it's big enough to use as a small corner desk.
We'll post a photo of it.
We'll post photos on
Yeah,
socials,
yeah.
Instagram and Twitter.
It's also got a plumb line on
Patreon?
it. So when I move it around,
We can see your plum.
You can see my plum is just dangling at the bottom of the protractor.
Can see why they confiscated.
Yeah, they're like, "Sir, your plum is showing."
I really wish we weren't in person now. I don't want to see this.
So anyway, so I made this, but I had to go through and individually notch equidistant little degree markings all the way around this. Very accurately.
I would argue the thing that can make it be useful as a weapon is that the weight that you've used, it looks like a large, heavy, it looks like a pencil.
Heavy pencil, yeah.
Yeah, and it's on the end of a string.
Well, you want to know,
which if you whipped that around your head, like...
That would be a weapon.
You've basically got a small mace. Yeah.
But the thing is, that wasn't even on there. Like, I had taken this off.
Oh.
For portability, and it was just the Perspex chunk that they objected
That's
to.
Matt knocking on the Perspex, by the way, not the security on the door.
You got plums in there.
They wouldn't let you take a large angular piece
of
what looks like glass.
Well, it's clearly like
That's
plastic.
Matt knocking on it again. Oh, no, that is the security. Yes, here he is. Yes. He's got his plum out.
And when they confiscated this, I was like, do you want the plum as well? And then they're like, yep, all right. But they didn't actually care about the weight. It was this. That was my month. I made a protractor and had it confiscated by security.
Have you ever had anything else weird confiscated by security?
I once had to get my Rubik's Cube put through a X-ray machine.
To make sure you weren't hiding any.
To make sure I wasn't hiding, literally to make sure there's no contraband in it.
Wow.
Because I was doing maths sessions in a jail.
Yeah. We don't want Andy DeFuane's spooning their way out of a wall.
with a Rubik's Cube.
Hello, lovely A Problem Squared listeners. This is Bec.
And this is Matt.
And before we jump into this episode, we just wanted to say we're aware that not everyone can be a Patreon supporter.
And that angers us.
No, it does not.
No, sorry, the other one. That's fine. It's fine.
That's fine.
It's fine. We
totally fine. But in order for Matt and I to be able to sustain this podcast, we will at some point need some form of income.
We're fussy like that.
Well, it's mainly so we can choose it over the other things. So that we have time to do this. Yeah. So here's the deal. If you would love to be a Patreon supporter, but can't, but for whatever reason.
Which is fine.
Which is totally fine.
We're disappointed.
No, we're not.
We're not. Sorry, the other one.
Stop trying to guilt people, Matt.
We're not disappointed. We understand.
If you could pause this podcast for one moment and tell someone about it. It can either be a direct message to someone that you know who would like.
A person? Like you were listening to this and you thought, I should tell that person.
Yeah.
Because this thing made me think of them.
Absolutely. Someone is listening to this who previously listened to an episode and went, oh, blah, blah, would love that. And then you thought you would tell your friend and you never did you?
You haven't. And now we are disappointed.
Yeah. So go do that now.
And angry.
Or you were not that angry.
No, I am.
Matt is actually furious. He's turning bright red.
This is as angry as I get.
Steam's coming out of his ears, everything. And if you don't want that to happen, tell someone. You can tell your following.
I'm also disappointed.
If you're on social media.
I'm
your friends and family.
Angry.
Matt's just going to keep going on about his feelings, which is fine.
You can put an end to this. Or leave a review on a thing or engage with an algorithm or just enjoy the podcast. That's fine.
You can do that as well. But that would be really helpful. And then we can keep doing this for you. That's the deal.
I'll keep my dango bottled up.
Keep your danger. Don't leave your danging.
Don't leave me dangering.
And now you can listen to the rest of the podcast. All right, let's answer some problems. This first problem comes from David from Greensboro.
Borrow?
That's how it's been spelt. And it says, if you rolled up graphene into a roll the size of a toilet paper roll, how long would it be?
So if you had a toilet paper's roll worth of graphene.
Yeah.
And
it says the size of a toilet paper roll. So I'm assuming when David says that, they mean the size of like a full proper roll of toilet paper, not just the cardboard tube.
Yeah, I assumed it was the paper on the tube, which just right out of the gates, there's some variation in this. I've gone with the 12 centimeter roll of paper with a 4 centimeter tube down the center. So you've kind of got your cylinder of paper.
Yeah.
I guess you can put it that way. And graphene.
Which I've only just realized that if you say a roll of toilet paper, you're talking about the toilet paper that is on the roll.
On the roll, yep.
Yep. A toilet paper roll is technically the tube.
Whoa.
Toilet paper is the stuff that's on the tube.
On the roll.
On the roll.
So the roll is the cardboard.
That's how
center.
I would
Is that how you would say? Oh, really?
But I guess the roll is a verb, isn't it? It
you
is.
roll
You are
it. It's
rolling
rolled
it.
around the tube.
Yeah.
And here in the UK, they're bog roll.
Yeah.
Roll is the noun.
I've taken us off on a tangent very early.
No, that's very true. No, okay. And so graphene, the wonder substance.
Yes. Explain I know vaguely.
What would you say is graphene?
I would say it's a very fine mesh.
Correct. I mean, that works for me. It's basically a single layer of atoms. So it's
That is
carbon
much more
atoms.
specific than I thought.
Yeah, well, this is why it's the wonder material. People have been trying to make it for a very long time, and they cracked it at University of Manchester. And it's basically a substance which is one atom thick.
Wow.
So you cannot get anything thinner than one layer of atoms.
Wow.
That's the one step up from nothing.
It's thinner
From
than a
zero
hair.
atoms, thinner than a hair. It's thinner than a human hair. It's a fraction of a human hair. And so it's
You wouldn't be
incredibly
able to see it, would you?
Nah, can't see it.
What if there's graphene in this room?
Could be here. Could be all around us.
Wow.
And it
is God graphene?
Yeah.
I knew it.
So it's amazing because it's incredibly strong for its size. It's like 100 times stronger than steel. This is an example analogy for its mass.
Right.
So it's only an
right.
atom thick. You could break it,
Yeah.
but it's got a million applications, none of which I think have actually come to market. But it's this amazing wonder substance because it's just a hexagonal grid of carbon atoms.
Mm-hmm.
And they're all hanging on to the 3 carbon atoms nearby. And you get this hexagonal. Exactly. It's an analogy for teamwork and super thin. Oh my goodness. So the first thing I had to do was find out how thick graphene is, because then I can work out.
Yeah. How thick is an atom?
How thick is an? Well, the thing is, it's not just how thick is an atom, because when you start putting atoms together, they do weird quantum-y interaction things.
Right.
So the thickness of graphene, and particularly in this case, we're going to stack graphene. And so the layers are interacting at like an atomic level as they're being stacked on top of each other. And so I initially just thought, piece of cake. I will Google what is the thickness of graphene. I will get the answer and I'm away.
Yeah.
No, there's no agreed answer. So eventually I found a scientific paper. This was published, the Institute of Physics put this out, and it's literally called Accurate Thickness Measurement of Graphene.
Oh, okay. Yeah.
And I was like, here it is.
There's your answer.
The answer on the plate. For free, you can read the abstract.
Okay.
And the abstract is this bit at the top here, this opening paragraph, which does not contain the answer for how thick is graphene.
Yeah. It's the trailer.
The free sample, the trailer, doesn't get, they tell you other ones are terrible, and they give the range. They're like, other measurements are between 0.4 and 1.7 nanometers.
What is a nanometer if you were to compare it to, say, a millimeter?
A millionth.
Whoa.
So a millimeter.
That's a tiny ruler.
So a millimeter is 1,000th of a meter.
Mm-hmm.
A nanometer is a billionth of a meter.
Oh my gosh.
It's tiny, absolutely small.
Yeah.
And so they're saying it's
That
around
is
there.
not getting rid of any poop.
No, and we haven't even decided if this is single ply. So this paper's like, look, everyone else is not doing a good job at measuring this stuff. It's too big a range. We need to know. Now, to read the paper, I basically emailed my wife, who's a real physicist, and said, can you send me a copy of this paper?
I was present.
I know, you were there.
She
you
was
were there.
in the room.
Literally, Lucy,
You
I've
were
emailed
like, this
you.
is business.
Yeah. Yeah. We separate business from pleasure. And I'm like, if it's email, business. I'm like, hey, I started. Dear Professor Green.
Nice.
I was wondering if you could download this paper for me and send it over.
And I saw her roll her eyes when she read. No.
Noun or verb?
She went, ugh.
So in their conclusions, they say the measured height of a sheet of graphene was found to vary depending on the force used to measure it. So what they discovered is if you measure it, you squash it. So the act of classic physics, the act of measuring changes it.
Is that like if you were to say that you were measuring my height and you put your hand on top of my head, but that pushes me
squash
down?
You. Yeah, exactly. Literally
so
that.
you're making me less. Yeah.
It's like I'm going to measure how big this roll of toilet paper is, but then like just crush it.
Yeah.
And then measure it. And is that accurate or not? And they found also in the conclusions, they say, if you apply a lot of force, you get close to the theoretical minimum, which is just the size of an atom. So,
Yeah.
so basically, they're saying if you really, really squash this stuff down, you're getting down to just a carbon atom.
Yeah.
But they almost grudgingly, I would say, do give a value of about 0.43 nanometers, give or take. So I've taken it to be roughly half a nanometer.
Mm-hmm.
So single-ply graphene toilet paper. Now, the next issue is how do you work out, like how long is it? Because you can work out how many laps. That's easy. You take the big radius, like the whole toilet paper roll. You subtract the small radius, which is the empty bit in the middle.
Yeah.
You've got the difference between them. You divide that by the thickness of the paper and you get how many laps, right? That's a piece of cake. But now the question is, how long is it?
So you've got to work out how, because it'll get longer each time, every time it does a lap.
Yeah. Each lap is bigger than the previous one.
This is an insane question.
Yeah. So now there's two ways you can deal with this now. You can either assume it's an Archimedean spiral, or you can just assume it's a bunch of circles. An Archimedean spiral is a spiral where it doesn't get bigger as you spiral out. So the classic, so the classic spiral, you get bigger and bigger and bigger. That's what you get when you wrap like rope or something around. It's spiraling out, but it's not getting thicker as you go. So the toilet paper is technically one continuous spiral coming out.
I don't understand. It is getting bigger though. What are you talking about?
But the rope isn't getting thicker.
No.
So a lot of
you're using more.
Yes, you're using more each lap.
Hang on, excuse me. At what point do you wrap something around and as you go around, the thing gets bigger?
Like if you're looking at the spiral in like a
snail
shell, or if you're moving in a spiral action, the distance between the laps of the spiral tend to get bigger as you go.
Yeah, it's like a Fibonacci.
Like a Fibonacci thing.
Yeah.
What's happened here is mathematicians have come up with ways to describe things that are otherwise super obvious.
Yeah.
For me, I'm like, oh, but it's this particular type of spiral where the thickness doesn't change. And you're like, you mean it's just exactly what you expect? It's like everything you've ever
with.
Exactly. Yeah. So I've gotten unduly excited about something that's super obvious.
And is that named after Archimedes?
Archimedes, yes.
Oh, the bath guy.
The bath guy. He may have said Eureka when he.
I know.
Everyone else around him is like, why are you saying that? It's super obvious. That's just what happens when you wind something up.
Yes.
He's like, but I gave it a name. Mathematicians are gonna be amazed for millennia. So I didn't assume it was a spiral. I decided that was too hard. I've assumed it's just lots of concentric circles. So there's like a circle that's this big, and then there's a circle that's that big.
It's bigger around
and then one that's
but
bigger.
That's not how it works. You're describing if you did a cross-section of a Russian doll.
Yeah.
But that's not how toilet paper works.
No, yeah. So I've approximated it as concentric circles because I think that's close enough within the tolerances of my estimation. If anyone wants to redo this calculation as a spiral, using a 12 centimeter diameter, 4 centimeter hole through the middle, half a nanometer width paper. I ran the numbers on, and then I rounded the answer, to be honest. So, frankly.
And we can see whether your answer and their answer is that much different.
Mine came out at 20 million meters.
That's a lot of meters.
It's a lot of meters, 20,000 kilometers. It is halfway around the Earth.
And you didn't think to go double ply?
If I went double ply, you get quarter of the way around the Earth.
Yeah.
So if you had a roll of double ply graphene toilet paper and you started unrolling it at the North Pole, it would make it to the equator pretty much exactly.
Wow.
Because the Earth is 40 million meters around. Like by definition, a meter is 1/10 millionth of the distance from the pole to the equator. It was the original definition of a meter.
Whoa.
And so a double ply roll of toilet paper is 10 million meters. And so we could have defined the meter as 1/10 millionth of a roll of graphene toilet paper.
Oh my goodness.
Because it's the same distance as the distance, double ply, same distance as the distance from the North Pole to the equator. So there you are.
Huh. And then the next question is, how many times do we need to fold it for it to be efficient to wipe your butt with?
Oh, yeah. Yeah. Like, I don't know what the strength would be.
I don't want my finger going through that.
I didn't look up the ratio of strength from toilet paper to graphene. It'd be pretty thin. I reckon it might be, I don't know, would it be visible? I think it'd be visible. Would it be like wiping
it will
with
eventually,
like,
won't it?
Well, it will be eventually. But initially, it's like you got invisible toilet paper. That's disturbing.
Yeah, I wouldn't trust that.
No.
How would you know?
How would you know?
Yeah.
Until it's too late. You wouldn't.
No.
Nah, no deal. Terrible idea. But anyway, there you go. And if you had 2 single roll lengths of graphene toilet paper, you could do the whole way around.
You could TP the world.
Yeah, that's
the ultimate prank.
One of Archimedes' famous sayings. Give me 2 rolls of graphene toilet paper and a place to stand, and I will TP the world.
He did say that.
I think that was him.
That was on a T-shirt I saw at the markets.
Oh, good.
I think I'm gonna give that a tentative ding.
Tentative ding,
because I wanna know if anyone gets the same or roughly the same with their other calculation.
Okay, or David from Greensboro. Let me know. We have a problem in from Patreon supporter Samson, who says, "My brother told me that every time he reads a paper book, he wonders how much the book would weigh without any ink. They also say, if you had a totally, in their words, totally useless representation of a book, how many pages could you save by just printing the ink without any gaps?"
Right, so just block pages.
Block pages. So take all the ink of the book and then just move it all to the front. So all you're doing is just fully black page, and then just whites, all the white spaces at the end.
Yeah.
So you've sorted the book by ink.
And then you get rid of all the white pages.
Yeah, you don't need them anymore. But you keep the ones that you printed nothing but ink on, just like block ink.
Very artistic.
Yeah, exactly. And technically, same book. Just all the ink moved to the front. So there you are. That's yet another practical, everyday life problem.
Yeah.
One of our listeners has sent in.
Well, I was excited about this problem because my first ever book, Horror Heights, The Slime, is being released the same time as this podcast,
Really?
actually. Yeah.
Wow.
So if you're listening to this on September 30th.
Was that a coincidence, or did you say put it out the same
I was
day as
like,
the podcast?
wait until a problem squared, please. So I was excited about this question because the publishers let me go to the printing.
I was so
press.
envious.
Yeah. So I got to see the factory.
You got to see your own book being printed.
It was so awesome, Matt.
Oh, that's so cool.
It was so, so cool. And there's this really cool moment when the cover is being glued on and all the pages are sort of being glued together and held together.
That does sound like the highlight of the book printing
It is
process.
the highlight. It's really cool.
When pages meet cover.
It goes onto a conveyor belt and then it sort of gets like, you know how when you imagine a factory and you imagine all the stuff being like
whizzing around on conveyor belts and assembly lines.
It's exactly that. Like it is exactly that.
They're like, look out, here comes the new edition, and you all duck and another row of them comes flying down
It's not dissimilar.
Fox-esque.
No, not a flying fox. They're they're lying on the conveyor belt. But I found out that the reason that because they go on the conveyor belt and then they go all the way around and then they like come back to pretty much where they were for the next step of the process. Yep. And it turns out that the reason they do that is so the glue can dry.
Oh, it's like a holding pattern.
Yeah, rather than it just sitting there, they give it a little tour of the factory first.
Which, as you can testify, good fun.
Good factory. Yeah,
Great
I
tour.
would do it. I would go on the conveyor belt. The other thing is that the books get printed. There's actually 2 in a long thing, and I'll put photos up with this as well.
Yeah, well, you showed me. You had like you stole a book from each stage of the printing process.
I didn't. I was given them, Matthew.
Oh, sorry. So in pairs before they've been guillotined
so then
apart,
they whip around.
They zip around the whole factory.
And then cut.
Books.
Yeah.
You get to see your own book being printed. That is amazing.
It was awesome. And the way that they print larger batches, so with batches of 5,000 or less, they do have these massive digital printers now where it works like a huge version of the way that you would at
print
home.
anything else.
In that you send the file directly to the printer and then it works out what to do. The way that the larger batches get printed, which is 5,000 or more.
Mora, that's the technical one.
Thank you. There's still a version of the way they did it in the sort of early stages of mass
movable
printing.
type.
You're not quite movable type, not like little clickety-clack things that you put together.
Oh, there's not some guy like twisting a press.
But it's sort of a version of that. So what they do is they make these big aluminium plates and then they put a large proportion of pages.
Oh, they etch all the pages in one big plate.
They etch all the pages.
It's like immovable type.
Yeah.
It
Yeah.
feels
So
like the
they've
same
skipped
thing.
the moving around the little clickety-clack
They just etch them
stampy
in.
things. They etch them in
Wow.
and then they go through a roller where the ink is applied to them.
Yep.
And the ink is like a mix of oil and water. And the oil sticks to the bit that's etched.
I was going to say rough, but there's something, the surface is different, so the oil sticks to it.
Yes.
And the water's like, forget that. I'll be over here in the white space. if anyone needs me.
Exactly.
That's
Exactly
amazing.
that. So then it gets transferred onto some paper, then transferred again
Oh.
because that would bleed really quickly.
Yep.
Yeah, like blotting.
Oh.
But it does mean, obviously, that you don't get a transfer of all of the ink onto the page. I haven't taken that into my calculations. I know it would affect it, but we're
Ooh, that's interesting.
doing
yeah.
what we can.
Yeah. And it's different book to, I mean, for my books, I use a specific photographer for the photos in my books because they will process the images in such a way to compensate for the way the ink is absorbed into the paper.
Yeah, right.
So the whole interaction between ink and paper is non-trivial and needs to be factored in to these processes.
Well, it's why often in books where there are photos, the paper type will suddenly change.
Yeah.
Yeah.
My publishers don't spend that much money on my books. It's cheap paper the whole way through. Yeah.
Fair. Yeah.
Yeah.
So I actually spoke to Beth and Ollie from Clay's Printing, who were the spokespeople, and I asked them the question that Samson posed, and this is the response.
It's really hard to give a definitive amount because each book is individual. Each book will have a different content, and it's the content that will determine how much ink is used. So basically, we looked at the text data that was supplied, and we could see how much of the text was comprised of images, how much was writing. Because obviously, if you're using text, it's 100% solid ink you go through, and depending on how many pages you've got, if you've got chapter breaks, if you're putting a blank page in after a chapter, but when you've got images, for instance, they could be comprised of tints. So you could have some part of that image that's only at like 40% ink density, and then others that are at 70. So all that sort of stuff could vary the result and the amount of ink is needed. So just by looking at that and the amount of images, we could give a really rough estimate. And it is really rough because there's the printing process here, there's big reels. It's not like little packs of ink, it's big, big amount
it's literally
of ink.
piped in, isn't it?
Yeah,
Like,
so there's lots of ink. So kind of work out 15 to 20 kilos maybe? Just to
for
do
the
this.
whole print run.
For the whole print run.
And then per book, we're looking at roughly 11.2 grams. Very specific. I said roughly, and then very specific answer.
So,
Yeah. That was the answer.
not quite.
Well,
That is the weight of ink per book, but they want to know how much the book would weigh without the ink.
my mass minus 11.2.
Exactly. So I managed to find the weight of the books.
Excellent.
So each individual book is 157.3 grams.
Right.
So Matt, you do the maths for me.
I've
Take away.
subtracted 11.2. It's 146.1 grams.
There you go. 146.1 grams is how much specifically my book would weigh without ink.
And actually, you know what? 11.2 divided by the original mass, 157.3, about 7%.
About 7%. There you
The
go.
mass of the book is the ink. And obviously, it's going to vary book to book.
Absolutely. I
But
could not
using-
find that out.
Horror Heights by Beck Hill out.
Yes. September
today.
30. Yes,
Yep.
today. If you're listening to this on the date of release of the podcast.
7.12% ink.
Yeah.
That's what you're getting for your money. That's the bit you're paying for, really. The ink.
Arguably, yes.
Arguably, yeah.
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 Which brings us on to the second part of the question.
Oh, yeah. How many pages would that be if it was block printed?
And I went to you for help with this because I was like, ooh, that's going to need harder maths.
Well, the printing people were no help.
I mean, to be fair, they print a lot of different books.
Yeah. And they don't care about the area of the print, just the amount of ink.
Yeah, this
right?
is not a thing that they have to work out. So why spend time on it?
No. New question for them. So, but you thankfully had your book in PDF form.
Yes.
So I wrote a bit of Python code to take all 176 pages.
Mm-hmm.
And the PDF you gave me is like the full print bit, but I cropped it down. I'm like the digital version of that machine.
Yeah, you are.
In the printing press.
Yeah.
I cropped it down to just the bit that's in the finished book. And then I wrote a bit of software to look at every single pixel in the PDF and see if it was pure white. So it's nothing being printed, or
Yep.
if it wasn't white, something was being printed there.
Mm-hmm.
And then I went through and summed them all up.
Which is incredible.
And
I was just going to guess.
Well, I've got a page-by-page breakdown. Do you want to know the most coloured in and the least coloured in pages?
I think I know which are the most coloured in ones.
Okay, what do you
Do you
reckon?
have
The
numbers?
most, yeah.
Okay.
What do you
right.
reckon is the most coloured in?
I would say that the most coloured in,
For reference, Bec is flicking through
My
a
own-
copy of her own book.
yeah,
Can I tell you one thing I did do?
no.
Occasionally, I'll tell you two then. Occasionally, there are greys
Mm-hmm.
where it would use half as much ink. I have pulled all that ink together.
Oh, nice.
So if there's two half bits of grey, I've just put them together to be a solid
That
bit of
makes
black
sense.
printing. Yeah.
I'm going to say page 167.
Correct.
Yes, because that is the very last page before the acknowledgements. Well, not the very last, it's the second to last page before the acknowledgements. And it is pure black, which
Wait.
is very handy.
85.47%
Oh, I'm sorry.
black. Just, roughly.
And I'm going to guess that that is to do with the CMYK values,
Actually, they were pretty well, I had to convert it to RGB. So
Yeah.
I've just got
which is not the same.
not the same. But once it's because they're all greys, once they're converted into red, green, blue, it's just the same value for all of them. So I just took the red value each time as a measure of how colored in it is as
Yeah.
a percentage of 255,
Mhm.
which is the scale. However, the crop marks is like an inner and outer crop mark. So the crop will be somewhere between the two. I've split the difference. And I think for some pages, like in the very middle where the spine of the book is, there's a little, even if it's meant to be pure black, often it doesn't print all the way in. So I've done the amount of ink put down. And so I think in the very center of like a 2-page spread, the bit you can't see that's glued,
Yeah.
I'm still including that, which is why maybe you're not getting 100% for some of these.
Oh, yeah. Yeah, because they don't need to print that. They're
no.
gluing it together.
Exactly. And do you want to know the page with the least ink on it?
Ooh, all right. This is a good one.
If you pick one, I'll be able to tell you where it ranks.
I'm going to say 104.
104.
Mm.
Okay, page 104 is the 6th
Really?
most blank page in the book.
Oh my
That
gosh.
is good. Wow. For just flicking through it, that is impressive, Bec.
Thank you.
And you're still going. You still want to beat your record.
No, I'm now looking. What about 15? Where does that come?
15, 9th.
Oh my gosh, that's
You're going
worse.
the wrong way. 14 is better than 15, according to my numbers here.
Really? Oh,
Does
looks like
that
more
check out?
writing to me. But no, I think you're right. I mean, I trust your maths
Maybe there's more
than-
gaps. I mean, I did a few checks. Like, I never trust my code completely. So I verified it, and I
Fair.
was reasonably confident. Yeah.
No, what's the least?
The page with the least ink, 32.
Oh yeah, there's not.
Pretty blank.
It's a page with dialogue on it.
Yeah,
So there's
and
a lot of gaps, not big paragraphs or anything. It's not blank. It's just there's a lot of.
Oh, no. It's still 2.1% ink.
It's what?
2.1%.
Wow, that's so small.
And if you add them all together,
Yeah.
move all the ink to the front,
Yep.
24.22 pages.
Wow.
Yeah.
And that is 24 out of 168.
Yep. Oh, 176. Because you got some pages before the numbers start. Your book starts on page -7. And then counts forward. Because page 1 is a fair way in, right?
Yeah, you're
Yeah.
right. Yeah. There's a note from the author.
I know what's going on
That's
there.
on a blank
blah,
page.
blah, blah, right? And so the 176 actual pages, at least in the print file you sent me. So the average is actually quite high. The average amount per page is 13.8% of a page. Which I feel like is a lot. But that's because you've got loads of pages with lots of slime on them.
Yeah. And in fact, I've done that thing where, when you're watching a TV show and it will be like London and it like has a quick heading.
Yeah.
Yeah. And it's like bum bum right in your face.
You've written bum in giant
I've
letters.
written bum. No, I've
Yeah.
written days though. So it starts on Friday and it's just a pure black page with Friday written on it in white.
And actually, this is interesting. It's a good example of why the mean is often not a good average because it can be dragged up by a few very big values. So if you just looked at the average of 13.8%, you're like, wow, that's a lot per page. But actually, it's just the all black pages dragging it up.
Yeah.
The median, so the if you reordered your book to be an ink order, the middle page would have 4.3% ink.
I mean, it feels like not much writing to me.
Yeah, you should put some more effort.
If I was
more
like, I've
words.
done a bunch of writing, I've covered this page in 4% writing.
Yeah, exactly.
But, ugh.
Oh.
I think you've helped with that. And of course, if anyone has any questions about the printing process, I'm going to chuck up a video that'll come up around the same time as this podcast on my YouTube channel, and I'll explain.
Oh, yeah, because you got loads more footage of the factory and everything else.
Yeah, it's real fun.
But given you went to the actual factory, because you asked to go and see it get printed to answer this question.
Yeah.
And you did the video.
Yeah.
And I've analyzed the percentage of ink on every single page in the book. I don't think we've ever dinged a question this hard.
Oh, yeah, it is
And this thoroughly.
specific. Samson, if you don't give this a ding,
Oh my goodness.
I'll ding you.
Yeah. We want more than a 13.8% ding. We want solid ding.
Solid ding.
Margin to margin. Finally, as always, we have some time for any other AOB business that we haven't covered so far. And I don't think we've got anything this time. I think the last episode was without correction.
Yeah.
So,
yeah.
other than the many, many people who were dissatisfied with my how far can you see answer.
And by the way, thank you to the people who congratulated me on bringing up the question of why didn't you include mountains?
Mountains. Yeah, I didn't include mountains. And people were very upset,
Yeah.
which I guess is fair enough.
Arguably with the surname Hill, I am going to be
You were
thinking of
pro Hill.
topography.
Yeah.
But for someone who did an entire video and problem about topography and how it would change the
Surface area and,
Yeah.
and nature. The problem is, as a mathematician, I just assume that the Earth is perfectly spherical. And that's the source of many of my problems in life, including forgetting about mountains. Okay, you know what? I was going to continue to stand by my policy of just looking at buildings
Yeah.
because it's how far humans can see. But you're right, you can go up mountains. And I was like, well, I need examples of people saying that mountains are superior because I think mountains, the trouble is how other mountains are going to get in the way of trying to see a long way if you're on a mountain.
Yeah.
And
but
so-
arguably that also helps you to see further away.
Yeah, well, okay. So anyway, people then did very kindly send in a lot of other suggestions.
Yeah.
So I apologize. I'm not going to name check everyone because there were so many people.
So many. And in fact, since we recorded that,
Yep.
I remembered that when I was in Sicily, in Mazzarino,
Yep.
which is like, sort of south, sort of central south, I could see Mount Etna from there on a clear day. And as the crow flies, that was about 86 kilometers, which I know that you were talking more about
We were
100
over 100,
kilometers.
yeah, but still.
But that,
You're right.
Yeah.
No, I agree, Bec. It was as much your fault as it was mine. So our eagle-eyed listeners, someone suggested Tenerife, which is the highest peak of Tenerife is 3,715 meters above sea level. And they say the other highest peak of Gran Canaria is just shy of 2,000 meters above sea level. And they reckon you can see peak to peak and it's over 100 kilometers apart. It's a great suggestion. Someone else said, oh goodness, how would you pronounce that? The tallest mountain in Colombia.
Pico Cristobal.
Okay, that works. And they reckon
Colon.
you could see
Colon.
the ocean from that, and it's over 5,000 meters tall. And if you can see to the horizon, actually, you know what? I will put the height of that peak in Colombia into my spreadsheet from last time, and it will tell us how far you can see. Okay, so from the top of that, you'd be able to see, if you could see the horizon on the ocean, it would be 270 kilometers away.
That's a lot of kilometers.
It's a lot of kilometers. So, I mean, they're not saying you definitely can, but they're saying it's a big old peak and you can probably see the ocean.
Yeah.
That's going to be impressive. There's a peak in Arizona where people reckon you can see Humphreys Peak, and that's 187K. If you go to Mauna Kea, where's that? Oh, in Hawaii. Oh, of course, Hawaii is going to be a bunch of like volcanoes with plenty of space in between. Someone reckons you can get 128K between two of those peaks. Mount Hood in Oregon. We've got a Aconcagua has a line of sight to the ocean again. Oh, it's even taller. Oh, you know what? They reckon that one's 6,962 meters. Let's chuck that in the spreadsheet. That's going to give us 298K. So that's pretty much 300K. If you
We
can
don't
see
have
from there.
visual proof of those, though.
No.
These are theories.
Well, this is it. A lot of people are just throwing theories at me, saying, what about this peak? No one's bothered to go up these peaks and check.
Or they have, but no one's decided to send us the proof.
No one sent us the proof. Or they didn't make it back. We don't know. We're not getting until several people sent me the world record for longest distance in a photograph. Like the greatest distance away from something and still taking a photograph of it. And that is from Spain to France. Someone went up the Pyrenees in Spain, mountain range, looked at the Alps. That's a fair way away, over in France. And they took a photo of the Alps from Spain. And there is a distance of 443 kilometers.
Whoa.
And what I love about that, because it's an actual photo, someone's done it.
Yeah.
The whole time I've been ignoring the refractive index of air. So actually, light will curve around the surface of the earth. So you can actually see further than is theoretically possible because you don't actually need a straight line of sight. The light will do some of the work for you and curl down so you can see even further than the theoretical maximum.
Is that how that that ship optical illusion where they look like they're floating because they look like they're sitting above the waterline?
Exactly that, because the light is bending in the different density air as above the water. It's why when the sun sets, you actually see it set slightly later. Like it's already set, but we can still see it.
Wow.
Because the light's, but then has it set? Like I think the
Trees
sun
falling in the
set.
forest. Yeah,
exactly. Yeah. So what I love about the photo is all of that's taken into account because someone's actually taken the photo. Like light has gone from that mountain all the way across Europe into a camera, and we know they could see that mountain 443 kilometers away. Now,
it actually says the Guinness World Record for longest line of sight. Like arguably, if you Googled the question in the last episode, you would have been brought to this answer.
Okay, there are two types of people in the world, Bec. People who just Google the answer.
This guy.
And people who start from first principles with a spherical Earth.
You.
Yes, and one of them would have got the correct answer a lot faster. But we would have less podcast content.
That's true. You would have missed out on all of our lovely banter.
I honestly can't believe if I just Googled. Like, what a cliche. If I just Googled Guinness World Record longest line of sight, I would have got the answer straight away.
You would have got it.
I can't, but anyway, I'm doing that from now on.
No, they'd miss all of our lovely colour and flavour.
That's the nicest way anyone's ever put.
Yeah.
Me trying to do it from first principles and getting it wrong.
By our, I mean mine.
Yeah, it's so true.
And I wouldn't get to feel smug.
Yeah, it's my top priority. Now, before anyone gets emotional saying, oh, but there was like a zoom lens or whatever, I don't care. This proves that you can see it. And if you want to do it by the naked eye, the mountain just has to be brighter. Like, or you put a really bright light on top of the mountain and maybe it's so bright to be visible by the naked eye, it's not feasible. I don't care. In theory.
You make it massive.
Make it massive. Exactly.
Massive disco hat.
You were so right.
Put a massive
Can't
disco
believe.
hat on the mountain.
You were like double right. Oh,
Yeah, I am. That I make total sense all the time.
443 kilometers is the answer. And frankly, is it my fault I didn't Google it? Or is it people sending questions into this podcast and not Googling them themselves before they send them in?
That's true. If you're sending
Let's
us a
split
problem.
the blame. Yeah.
Yeah, I'm willing to give them that.
I'm assuming if we get sent a problem, you've exhausted the just Google it option.
That's true. Yeah. Why would you make us go through
Exactly. I slam straight into assume the Earth is a sphere and work my way up.
Yeah, that's fair.
So there you are.
Yeah.
443K.
I'm going to give you a solid ding now.
Thank you. What's a solid ding sound like?
Ding.
That is a solid ding.
And quick, any other business? We had a bunch of you respond on Twitter to share your tips for making writing more fun.
Yep. Thank you very much. My favorite was use one of those pens that vibrates.
Yes.
That that fits the bill.
So if you want to see the suggestions that other people put, you can just check out our Twitter account and see
Yeah.
what people reply to.
Writing would be more entertaining. And we have a ding in from Positronic Girl saying that your solution to how close can the human voice get to making a real ding sound was adequate.
Yay! Thank you, Beardy Man.
It's been dinged. The ding is a meta ding.
Meta ding. For anyone who hasn't listened to that episode yet, go back and listen to it.
Yeah. Right. And I think that's it.
Yeah.
I have been Matt Parker, Bec Hill as always.
Yes.
It's been edited and produced by Lauren Armstrong Carter and supported by all you fantastic listeners and Patreon backers. So thank you very much. We love you all equally.
Yeah.
Yeah.
Especially you.
Bec, have you got a card?
What, on me?
No, like in your mind. Pick a card.
Okay. There's so many.
You got it?
There's like 52 that I can choose from. Can I choose jokers?
You cannot.
Okay.
You got it?
Yes.
Okay, next time I'll guess it.
I've switched it now just in case.
No.
All right, I've got it. In fact, I'm going to message our producer, Lauren, the card that I've thought of
That's such a good idea.
so that I can't forget it.
Do it.
Okay.
Keep that card in your mind and your sent messages.